Hello, I'm Dmitry Mikhailov, an engineer from the Cisco IOS XR team. In this series of videos, I would like to discuss a few available tools used while investigating control plane protocol issues on iOS XR devices. Each tool has its own strengths and limitations. Understanding them will help us selecting the best tool for a given task in order to get the most valuable data and avoid pitfalls. The most common tools are the process debugs, so let's start by looking at how they work. In a nutshell, debugs are simply a series of messages that a process may display as a response to certain events. Debugs are user-friendly, but can consume CPU, and despite being quite verbose, often it is required to run several debugs at once to get all the relevant data. Last but not least, to print debugs, a process would always require some kind of trigger, such as the reception of a control plane packet on process level. For example, the debug output from a border gateway protocol process for an incoming BGP packet suggests two things. First, the packet has been successfully received by our network interface. Second, the packet has made its way to the BGP process level. If debugs fail to show traces of our packets, it would prompt several questions. Did the BGP packets reach our process level? If not, where and why were they dropped? Most importantly, did these drops occur inside the device or before reaching our network interface? To answer that last question, we can try capturing traffic directly from the network interface to get the evidence of what is happening on a wire. Unfortunately, this approach isn't always feasible due to potentially high interface traffic volume or other factors, such as the availability of a packet capturing equipment. So, what other options do we have when both process debugs and interface capture tools cannot provide us with the answers we are looking for? I'm glad you asked, and in this first episode, I will show you a less-known technique for collecting control plane packets with the built-in tcpdump tool. tcpdump is a common Unix utility for capturing network traffic, which can also be used internally on iOS XR devices. The tcpdump is available on the 64-bit iOS XR software or eXR running on Cisco platforms such as the ASR 9000 or NCS 5500. Before we dive in, let me first clarify a few keywords we're gonna be using going forward. To start with, any packet handled by the device local CPU is called for us. Next, let's take a look at how these for us packets reach our process level. The incoming network interface traffic is always a combination of transit packets and some locally destined control plane packets. Incoming packets on the line card or LC network interface will reach a network processor unit or NPU, where for us packets are redirected towards the local CPU, an action called punt. To reach the line card CPU, punted packets will follow a green pathway via a control Ethernet switch, acting as a bridge between CPU and NPU. The transit traffic will use the orange path towards the fabric. Control Ethernet switches from each line card are interconnected as an internal Ethernet control plane network to which the route processor or RP have access. A punt interface is a generic term describing a control Ethernet interface used to deliver control plane traffic to either RP or LC CPU. So, with all those definitions out of the way, the main idea of this video is to use the tcpdump on punt interfaces available from the RP or the LC shell. The access to the RP shell is straightforward. However, connecting to the LC shell is more platform dependent, so stay tuned for our upcoming videos on this topic. The most common use case for this technique is to capture routing protocols packets punted to the RP CPU. Let me show you the next steps by using our lab NCS 5500 router. First, I will connect to the RP shell using a run command from the XR command line. Second, I will confirm the punt interface for our capture. That interface is platform specific, as you can see in this table. Instead of trying to remember it, the punt interface can be found by reading the bootstrap config file named calvados_bootstrap.cfg and searching for the guest1_punt_eth string using Unix cat and grep commands. cat/etc/init.d/calvados_bootstrap.cfg pipe grep guest1_punt_eth in uppercase. The output shows the punt interface as ps-inb.1538, which we will use with -i flag to set the tcpdump capturing source interface as our final step. Unfortunately, tcpdump couldn't display those punted packets in an easy-to-read format due to the presence of additional iOS XR system headers. To overcome this, we will dump full packet, including all headers, in hexadecimal format by using -xx flag and then use hex patterns to search through the result. This wraps up our first episode. In the next one, I will show you a few simple and advanced packet filtering techniques and how to export packets in a pickup format for later analysis. Thanks for watching.